So first things first, machine learning is a lot of things. Okay, I know. Okay, we are going to use this as a YouTube video later on. I'm just going to clip this. Okay, so let's start. Oh, you have AI/ML as a subject. Okay, perfect. So what I want you guys to understand in very simple terms is that machine learning is not one thing. It's a lot of different things. Okay, it's a lot of different things, from mathematics to linear algebra to a lot. Okay, what I want you guys to do is forget everything you know about machine learning, AI, anything that you have heard. Forget about it. Okay, if you think AI is ChatGPT, forget. Not exactly. We will discuss. Okay, algorithms, not exactly AI. Okay. The thing is, nowadays people are using AI everywhere where it can just be a very simple if statement. People are using AI that, hey, this is AI powered, this is that. But in reality, that's not the truth. We have been using AI since a long time. We have been using AI for our Google Maps. We have been using AI for Google Images. We have been using AI every single time we do voice to text, right? Every single time we speak something and Google understands it, like our Gboard understands it. That is AI. We've been using that since 2013, 14. In fact, your algorithm that you have on your Android for like battery management, it uses AI. It uses machine learning. In fact, even if you go back a little further, for example, if I were to just open up, let's say, let's open up the default weather app. So if I were to open up the weather app right now, this is my location, right? So this is showing my location, and this is saying that, hey, Ahmedabad, this is what a critical alert, whatever, go away, right? That, hey, this is what is going on. This is the temperature, all of this. This, we have had weather apps since what? Long, long ages, like long years, like what, 10 years, 20 years. This is AI. All of this simulation, all of this is AI, this is machine learning. How do you think that I can predict that tomorrow, that when I'm going to go watch Deadpool in the morning, it is going to rain? How do I know that? How do I have that much information? Because this is machine learning. This is what is happening behind the scenes, right? So yeah, this, we have been using machine learning and AI since a long time. In fact, if I'm not wrong, it has been since around before, like, we have the digital computers we have. It's like 1960s or 70s or something. Before internet was a thing, machine learning has been a thing. And it all stems from a very basic thing. In fact, if we search for the first machine learning paper, I'm not sure, but I think it goes back to, yeah, 1950s. Okay. Suraj has already did after attending college lectures. I think you are referring to the fact that you forgot everything. Never mind. Okay. So even before 1950s, we have had statistical methods which were defined and refined. Then you have machine learning research that is happening using simple algorithms. Then we have Bayesian methods, which is like, just probability and stuff. We have a lot of things, right? And then in 1980s, so I would consider, say, up till now, it's just algorithms. In 1980s, they discovered something known as back propagation. Okay, what you guys are learning right now. Okay, so what you guys are learning right now is, maybe you are learning something about neural networks and stuff. So I'm just gonna try to draw a very simple neural network. If I fail at it, give me 1 second. Let's just do. Let's just do one over here. Let's try to zoom out. Okay, let's copy the whole thing. No. That is not what I wanted to copy. Let's try again. Copy, pasta, and okay. So consider this a very simple neural net. Okay, I know you guys are maybe like, hey, what is this? Why are we drawing suddenly? Uh, Suraj, I hate you. I know the cameo. Can you like just not do uh like spoilers for Deadpool? Okay, I haven't seen it, but I know the cameos. Okay, so how about let's not do that. Okay, as I was saying, consider this like a very single neural net. Okay, so I'm gonna try to draw a few lines from here and there. which might make sense in a while. Uh, this is going to take a while. Give me a second. This is a very tedious process. Okay, so some nodes are connected, some of them are not connected. Uh, I should have just used, okay, neural network image. Yeah, you know what? Steal when you can. Okay, guys, always remember if someone has done something better than you, just steal it. Instead of trying to recreate it horribly, just steal it. Okay. Yeah. So let's just steal diagram from geeks, because you know what? That's good spirit. Anyway, so we have something known as input layers, we have hidden layers, and we have an output layer. Okay. Now, what I want you guys to understand is this might look very daunting. This might look like very crazy, like, hey, what is going on? But in reality, it's just linear algebra. Like, what do I mean by that? So what I'm trying to tell you is the input layer over here, okay, this has just some numbers. Okay, so we'll go to the original diagram. Okay, and if I try to zoom in over here, and let's say this has I don't know, 4, or let's just keep it between 0 and 1. So let's say this is 0.4. Oh, I think it's because the length is bigger. Let's just do medium. Okay, so let's say that is 0.4. This is 0.2. And then let's say this is 0.43. Then sure. And then let's just put some value over here, which is like say 0.9. Okay. Now let's say these are just stupid numbers, whatever that is. And then you have these lines, and these lines also have some sort of numbers. So let's say this line has 6. Okay. Let's say this line has 3. Let's say this line has 8. And let's say this line has 11. Okay. So we have these certain numbers, and that's basically it. So this node, so this specific node that I'm moving my mouse over right now, like this specific node, let's just try to zoom in, control. So this specific node will have the value. Okay. Okay, guys, shut up. Come on. Let's not do spoilers. So this value will be 0.4 times whatever this is. Okay, so this is what my node is. So this is what I would call a node. And this is what my weight is. Okay. So what I would do is if I just multiply both of them together, so like this is 0.4, this is 6. So this would be what, 2.4. Okay. So that will be the value over here. That is 2.4. If we do that for every single node, okay, if we do that for every single node, and if we get to the original, diagram over here, so let's actually go on the internet, find something interesting, which might have, as I said, guys, we always steal, so yeah, we have inputs. Let's just take this as well. Really good image. We'll just steal it. So let's paste it over here. And yeah, as I was saying, you just have a summation function, and that's it. You just pass it on to the next node. So we have this F over here, like we have this output. So that is like every single node in the hidden layer. Okay, it's just mathematics, pure mathematics. And what will happen is if we can just have one example. Yeah, these are the inputs, weights, whatever. Okay, I think this is a good one. Let's just put it over here. Yeah, so if you look at it, this is what is happening basically. Okay, and then you have a summation, and that's basically it. If you have more than one nodes coming to a specific place, so let's say 0.2 was also going here, which is completely possible. You don't have to have one node per one, inner node. So let's say this value could be 7. So in reality, then this wouldn't be 2.4. It would be like 6 times. So I'll just write it over here. 6 times 0.4 plus it would be 7 times 0.2. Okay, and then whatever is the answer will be the final value. So let's just do it very quickly. You would have 2.4 plus 1.4, and that's going to equal to what, 3.8. And so this value would now be 3.8. And that's just it. It's just mathematics that is happening. Now you might be wondering, okay, how is this even remotely related to ChatGPT? Like, how does something like this become an algorithm? Like, how does something this complicated look like an algorithm, or how does it even become a neural network or machine learning or anything at all? Well, that's the thing. what I would eventually do is, so let's say I have my input layer. So imagine all of these are filled with something, something, something. And in the output layer, let's say I only have, is there a way to hide? Let's try. Can we fill it? Give me a second, guys. Trying to figure out something. Okay. So imagine if we only had two outputs. Okay. Okay, maybe we can kind of do colors. Give me a second. Let's just do white. Okay, so imagine we only have two outputs. Okay, let's say this output is dog. Okay, let's just increase the size of dog. And let's just say this output is a cat. Okay. Now imagine after doing all of this, let's say I'm putting some image over here. Okay, now the input layer will have pixels of the image. So let's say image is just, let's say you put an image of dog. So let's just search for a dog very quickly. Give me a second. Dog. Let's pick up you know what? German Shepherd should be fine. Or let's pick up this dumbass, this Chihuahua. Okay. We don't like Chihuahuas. Chihuahuas are horrible. Okay. So let's just put Chihuahuas over here. So imagine this little hell spawn is our input layer. Okay. Now, how would this be an input layer? So what you would do is you would go inside the array. Okay. So you would actually find out the pixels. So let's actually do that as well. Pixels of image online. I don't want to resize them. I will look at the pixels. Image pixel converter. Let's see that. Resizer. No. Okay. Give me a second. Oh, wow. Hey, we don't get political over here, guys. Now, see the pixels of an image. I don't know. Can we do that? Okay, so if you look at it, if I click over here, we can actually see that this is the pixel value. Okay, so if I let's just take the nose. So this is the pixel value. If you guys can see it, this is 108/8268. That is the pixel value of red, green, and blue. Does that make sense, everyone? Hopefully, yes. Can we all agree to that much? So this is the formatter. We are using RGB. We can also use RGB and amplitude function, which will just tell us what is the like kind of an amplitude, like, hey, how much are we using this? But that's completely fine for now. We'll just use this one. Okay. I hope that is making sense for everyone. Okay. Now, but that is not what I wanted to do. And let's just go back over here. And if I, for example, were to take this pixel and it just looks like 10, 11, and 13, so which is very close to black, like you would have 0, 0, 0 for black. This is the value over here. Okay. Now, what do I do is I take all of these different pixels. So you guys can see the pixel, right? I take all of these different pixel values and I would put all of those pixel values inside the input layers. Okay, so let's say this image was 256 by 256. What I would do is I would have an input layer which is 256 by 256 layers long. Okay, so my input layer would be 256 times 256. So that is what 256 times 256. That is like 65,000. These many thing. Let's just try to increase the size. So this would be the size of my input layer. Okay, this would be the size of my input layer, and every single layer will have pixel values. Okay, now because this is RGB, what I would do is I would not use this image by itself. I would convert this image into a grayscale image, and then I would just use the value of brightness, and that will be inside the input layer. Then I will have some hidden layers. I have no idea what are the values of hidden layer. We don't have to do anything. It could be random values, and then I would have random values in all of these lines as well. And that's basically it. What I would do is then I would have an output layer. Now, I would have a lot of different functions. I would have like some sort of normalization function. So I don't know if you guys know what is a normalization function, but let's say I have some values. Let's say I have 4, I have 6, I have let's say 8, I have 10. Okay, let's say I have these different values and I want to normalize them. So if I were to normalize them, so let's just find normalize values online. So let's just go to a calculator and let's just put some values inside it. So I'll just put 4, 6, 8, 10, 12. So if I will normalize them, these are my normalized values. So what I'll do is I'll find the middle point. That will be my 0, 0. And then each side I would have minus values like -1. I'm just normalizing the values. Okay. So after normalizing, so yeah, we have the mean, like consider it a mathematical function which would reduce the values in, let's say, 1 to 0. Okay, I believe right now they're normalizing it as a z-score, but I want to normalize between 0 and 1. So yeah, basically this is what you would do. You can check it online how you would do it, whatever, whatever. I'm not going to go through it, but this is what you can do. This is the function. This is what you can do. So because of, normalizing of those values, right, I would get an answer over here, which is between 0 and 1, and this is also between 0 and 1. And when I add them together, it should add up to 1. So this means, let's say the dog value is, let's say, 0.6. Then the cat value has to be 0.4. That's the only way, like it has to add to 1. That's the entire point. Okay. But you can, so for example, a neural network, that means is like what, 60% sure that this is a dog, and it is 40% sure that this is a cat. Now we know the answer. We know the answer that, hey, this is an actual dog. So we will tell it. We will tell it that, hey, you are wrong. This is a dog. I want this number to be higher and I want this number to be lower. So what I'll do is I'll change some weights. I'll change some values over here in the hidden layers. I'll try to do something, I would try to find the gradient function. Once again, this is incredibly complicated and it is really difficult to explain online. Like I would have to draw a lot of different things, and maybe we can do it as a regular series. But I would change some values over here in the hidden layers such that this output layer, because it's just mathematics, guys, it's just mathematics. I can change some values in the hidden layers that every single time I give this picture of dog, it should say that dog is 1 and cat is 0. Like it is 100% sure this is a dog, it is 100% 0% sure it's a cat. Once I start getting this, this is my first image. Okay, this is the first image that I'm using. Then what I would do is I would go online and then I would get second image. Okay, so let's just take the second image and let's just use that. So now I'll use this image. Now, obviously, it will try to guess something that it would say, okay, this is 0.3 as a dog. And let's say this is 0. I don't know, 7 as a cat. Okay, once again, this is completely random. Okay, then we will tell it that no, 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 hey, you are wrong, you are wrong. This is actually 0% cat. Okay, so we'll just say that, hey, remove whatever you have. This is 0 and it is actually a dog. So make some changes over here to make sure that the output is always this. So now the neural network has to always make sure, okay, if I give this image, it has to say 100% dog. But even if I give this image of a golden retriever, a puppy, it still has to say 100% dog. And because there are so many variables and so many functions in between, you can tweak the values in such a way that this is what it is satisfying. Like this is satisfying a specific equation, and that's it. You can keep on training it on and on and on and on, like for like let's say 10,000 different images, and you can make sure that every single dog is always categorized as a dog. And then you also give it cat images that, hey, every single cat is always categorized as a cat, and that's it. That is what training is. That's how you train a machine learning algorithm. Okay. Once training is done, we show it a new image. We show it a new image of maybe a dog or maybe a cat. And then we ask that, hey, is this a dog or a cat? And that's it. That's what machine learning means. And then it can probably give us an answer. Once again, we do not know the hidden layers. We do not know what is happening in the hidden layers. We cannot actually, like, we can look at the weights and biases. Okay, we can look. So this is what the weights and biases are. We can look at it, but we can understand what one neuron is doing. But overall, as a whole, we will not be able to understand what is actually the computer thinking. Okay, so this is the weights and biases. Okay, so every single line, as I mentioned, this is the weight and bias. And the reason I said this is very important is, if you noticed on Open Router, when I actually opened that, let's say the Llama 3 page, Let me just open up Llama 3 page. You can notice it says over here model weights, like the weights of the model. And these are the weights that we are discussing over here. Like these are the weights of the hidden layers, because this model is open source. Not just open source, meaning you can download it, meaning that you can actually see what is inside the layers. And maybe you can use that to, change it to something else. Maybe you can ask it to do something else. Now, what now every single time you hear parameters, like there's like 405 billion parameters, 7 billion parameters, 10 billion parameters, what are we talking about? What are these parameters? So parameters are these connections. So these connections that you see and the layers that you see, those are the parameters in a very, very, very rough sense. So the next time someone tells you, hey, ChatGPT has like what, let's say 8 billion parameters, or Llama 3 has 7 billion parameters, they're talking about the number of nodes, roughly, I'm saying this is very roughly, the number of nodes in the hidden layers in the whole neural net. That's what is actually at the core of machine learning. It's actually just statistics and a lot of mathematics. Hopefully that is making sense to all of you. I know this took like what, 15-20 minutes, but yeah. So yeah, this is where the YouTube clip ends, or whatever. If this is supposed to go on Instagram, that's where this clip ends. Thank you for watching. Subscribe to like YouTube channel, eStudy, or whatever.